Hello, I'm Adam, and this time I'm in a camper and I want to show you something very nice that I created. So if we go up, we can see there is a Victron MultiPlus, and yeah, I simply created a 230 volt power converter, inverter, yeah, whatever. And in this video I just want to show you how I did that, some useful tips and tricks. So at the very beginning, let's talk about MultiPlus. It's from Victron, and what I've got connected there. As we can see, of course, there is a battery, plus and minus. Then we've got two Ethernet look-like cables. First one is V-bus, which is connected to this Victron MultiControl Panel, and I decided for this display because there we've got nice control how many amps we can draw from the campsite, from the shore, and there is a very simple off button. And now 230 volt is shut down, so there won't be a power. Yes, and going next, we've got of course some AC cables, and there is a V-CAN. The first one is terminator. There is just a resistor between CAN low and high, and there is a BMS connection because I successfully connected it to the BMS. From other informations like battery cables, Victron recommends up to 5 meters, 50 square millimeters. So yes, pretty beefy cables, and of course because of we are in camper, we need to use rubber cables, not standard one, because despite low temperature those will be flexible and those will be fine. That's the case. And two words about Victron itself. As we can see, there is a model which is rated for 24 volts, 3000 watt ampere, 70 is the current that it charges the battery, and 32 is the amps that you can pass through. It's regarding AC. And the GX is about the built-in turbo. It's some kind of a system where you can set everything up and control everything. It's normally Linux based, etc, etc, Venus OS or something, something like that. Okay, so if we spoke about Victron, if we spoke about the multi-control, as you can see there is no touch display from the Victron. And to be honest, I intentionally skipped this part because it's not needed. And you can save about 100 euros, so that's the case. Okay, now that's how the battery bank looks like. And what we can see there, I used flexible bus bars, and I use JKBMS, which I need to fix it like this. I will print enclosure later. And what else? We've got the JKBMS, which is rated for 200 amps, which will be very enough. And what else? So going from the plus side, as we can see, there is a plus, there is a 300 amp fuse. Then we've got safety switch. Then we've got two bus bars, one for the plus, one for the minus. And there goes beefy cables to the Victron. There is a fuse which we go further, that will be later about it. And of course there are LiFePO4 Battery Bank. I used their EVMB31, which nominally has about 310 amp hours, but tests are reporting for something around 330. And what we've got there, I mean, okay, cells which are getting wet because of the temperature difference, but be aware of that. But I think it doesn't matter because anyway it's sealed and whatever. I will close it, and yeah, temperature will be fine. What we've got there? Of course, we've got very good mounting. As we can see, there is one screw, there is another screw, there is one screw, there is another screw, and same on the other side, because this thing is pretty heavy. One cell is like 5.5 kilograms. So yeah, and it needs to be pretty good mounted. And what next? As you can see, there are rods, and there is a 4mm stainless plate, and the whole pack is tightened up. Why? Well, because that's how the data sheet and yeah, EV recommends. For those type of cells, we need to tighten them up, and they are saying from 300 to 700 kilograms of force, which is a lot if we consider, oh my gosh, 300 kilograms, yeah? But if we go to the detail, for example, if I've got M8 rods and 4 point of them, and it's like 5 centimeters from the top, so it's about even, yeah, evenly pressed. You will realize that you have to tighten those screws by like from 2.5 to 3 Newton meters, which is, I would say, barely nothing. But if you screw every screw like this, I mean the 2.5 Newton meter, in total it will have a compressed force about 300 to 700 kilograms. Yeah. What else we can see? Of course, there are separators between those cells, and there is a small detail. As you can see, there is a silicone pad. It's 2 millimeters, and on both sides. And I've got that because those cells anyway can a little bit be swollen, tiny bit. So those silicons are about this tiny bit, giving space for that. Because if it gets swollen, it still be better to compress silicon instead of fight with rods, yeah? Yeah, so that's generally how the electrical part looks like. And if we close this thing, we can see the BMS display. And to be honest, is it worth it? I would say yes. Because as we can see, it's in English. Generally we don't have to set anything there. Of course the Bluetooth application is working, but what's most crucial, in this case we can see exactly how many voltage or the capacity of the battery we've got. And simply we see our power consumption and remaining capacity, as I said. And yeah, it's pretty handy, and I must say that choosing 8 kilowatts of energy was a great idea, because guys, well, simply you can have air fryer, electric grill, or yeah, hair dryer, anything you can use there, and it works flawlessly. Even you can use electric heater, the PTC one, etc, etc. So generally that's a very good thing. But what's most important is this thing. There we've got a AC unit which can heat and cold, which has heat and cold. And what's crucial about this thing is working at 230, and if we are traveling, the AC from the car itself is available, of course, but the whole let's say camper part is not doesn't have AC. I mean the cooling, yeah. So that's the case that we'll have AC during traffic, during ride, and that's a crucial thing why it got built there. Another thing is that how Victron is cool. I mean this panel is saying this panel is showing for a feature which is totally out of this world, because in this case, if we've got at the campsite shore that has 6 amp, so we could safely set it to 7, and it won't break, because standard circuit breakers has at least 113% of headroom. So if we've got 6 amps, we can draw 7 amps, and generally we are maximizing power that we are receiving from the shore. And as we can see, 7 amps from the shore is not enough to power air fryer or something like, I don't know, even, okay, portable small coffee express would be fine, but yeah, anyway, you know what I mean. For example, breakfast for whole family, and you need to have powerful devices, yeah, or to dry your hair, yeah, and 7 amp is not enough. And Victron is cool in this mean that 7 amps is not enough, but I'm turning on the, I don't know, hair dryer, and it will add additional power from the battery. So, summarizing, we will use 7 amps from the shore and I don't know, 3 amps from the battery, because we can, and it allows us to use very more powerful devices, or even charge a Tesla. Yes, yeah, that's the main reason why the Victron is so expensive, why it's so good, because it also acts as a UPS device. So yeah, that's very good. To be honest, this knob is too loose. And okay, so another thing is about, as I said, there we've got JK BMS, and on top we've got Victron. As you saw maybe on the display, if I turn on the display, I simply got in the settings Victron canvas, and fortunately, yes, I can say I am amazed that the JK BMS is working with the Victron MultiPlus without any advanced configurations or something. I just had to make special Ethernet cable, because pinout from the Victron differs from the pinout on the JK BMS. So simply I will post you a schematic for this cable, and simply you just connect it. You set in the JK BMS settings the CAN bus communication schematic, and in Victron you have to set baud rate to 500 and BMS, and it will be visible in Venus OS, and it will work flawlessly. And I'm amazed that something Chinese like JKBMS works with something very good and yeah, powerful, and yeah, wow, I'm impressed. How this battery charges? If you connect a camper, let's go one step lower. Okay, yeah, so there is a Victron panel, and how does it work now? Let me see it. Okay, yeah, so currently, if we connect camper to shore, this is this cable, and in this cable electricity flows in. There is a RCBO, so the RCD with MCB it's combined, and it goes to the MultiPlus. Yeah. So yeah, as we can see, there is a test button, and yeah, that's how it works. It's this is needed for securing a cable to the Victron. Yeah, that's how it's supposed to be done. And and I'm coming back from the AC out to this original camper fuse box, breakers box, and this is very standard that we've got yeah, 2 fuses and 1 RCBO, RCBB, whatever, you know what I mean. And yeah, that's how it works like. And the charging speed is determined by the amps that I showed you on the panel, and that's how the main battery charges, and we've got 230 volts. In this case, the electric diagram for this camper for the AC was pretty strange. Like, we've got their AC input, we've got MCB1 which everything is connected to, and MCB2 was free. So I decided that I will install to this MCB2 additional socket, and the socket is there. As you can see, yeah, just very standard socket. But what it gives me? It gives me one socket, which I know that I can draw a lot of power from this socket because it's alone on this breaker. Yeah, that's the case. Additionally, if we could add solars on the roof, what we would need? We would need their MPPT controller and, I don't know, 2 or 3 solar panels, and tied it to those bus bars and connect MPPT to Victron MultiPlus GX. That's the case, yeah. And in GX we can configure everything because it has own system, yeah. But in this case, I didn't went for solars because of the weight. Because campers are generally heavy at the very beginning, so the plan was to don't load it up. And another thing that I had to modify was I had to remove previous battery charger, the hotel battery charger, and the AC battery charger. And in this place I have put 2 Victron nice things. The first one is Orion TR Smart, and this thing is non-isolated DC-DC charger, and simply it charges the big battery from the alternator. So if engine is turned on, we've got charging, and it charges, as we can see, maybe you don't see, 360 watts, so 15 amps. And generally it's great that, and I would say it's very good replacement for solar panels, because if you travel, you charge, and 15 amps is, I don't say it's enough value for charging that big battery, because yeah, 310 amp hours. But if you will ride for like 5 or 10 hours, let's take 10 hours, we've got like 150 amp hours, so half of the battery, which I think is a better result than having solar panels, because you are yeah, you rely on the sun. Yeah, that's the case, and I think that would be better option. I don't know, for sure lighter, yeah. And that's the thing on the right. Second thing is on the left. It's Victron Orion 70, and generally this is just a DC to DC converter, which converts from the, I don't know, 26 volts from the this battery bank to standard 12 volts for the rest of the system. Because in this case I have removed the previous hotel battery, and I replaced it with a very strong power converter. And yeah, generally that was my intention, because 110 amp hour standard hotel battery weighs about 26 kilograms, so it was great to remove it and install the 1 kilogram converter. Of course I used original cables, and there is even fuse. And yeah, because summarizing what I'm using there 12 volts for, and for example for light, so I've got, yeah, I can turn off and on light, and generally, yeah, some kind of like pump or those or those sockets are powered from this converter. So generally I would say 17 amps seems very enough for this purpose. And yeah, I reduced the weight of the additional battery. Yeah, if you have any questions, just feel free to ask. And yeah, that seems to it. Thanks for watching, please leave a comment and hit the subscribe button. Bye!